let's take a look at the warm-up problem together and see how we're doing. It's similar to the ones that we did yesterday, right? The big difference, as we said before, is that instead of it being an elastic collision where they bounce apart, now they're sticking together, so we've got an inelastic collision. So, and then the other thing that I wanted to kind of remind you here is just that this chart is really just to help you get yourself organized. There are a lot of givens, a lot of things that we need to keep track of. All right, so we got two different objects. What are my objects? A car and a truck. The mass of the car is 1,500 kilograms or 1,500 kilograms, and its initial velocity is? It is 15 meters per second. So does the car have momentum at the beginning? Yeah, how much? You say it loud so I can hear you. Thank you. 22,500 somethings. 22,500 what? Kilogram meters per second. It's kind of a cumbersome unit, but that's what it is, and we'll go with it. Let's talk about the truck before the collision happens. The mass of the truck is much larger. It's 4,500 kilograms. But is it moving before the collision? It's not. It's just sitting at the, was it a red light, right, or a stoplight? Yeah. And so how much momentum does it have? Zero. None. Kilogram meters per second. All right. So then they're going to collide. The masses are going to be the same before and after. So that's 1,500 kilograms and 4,500 kilograms. Do we know the velocity? We don't. But the thing that's important and that's different about this one from the others that we've done so far is that the final velocity for both of them is going to be the same, right? It's an inelastic collision. It says that they stick together. So it's an inelastic collision. You can just write VF. You just say it's VF for both. And so then we could fill this in as 15 or 1,500 VF and 4,500 VF. Or if it makes more sense to you, you can just tell me the total final momentum of the two cars stuck together. How much mass is there that's stuck together? 6,000 kilograms, right? So it's going to be 6,000 times VF. Either way works. So that's just our givens for the most part, right? Standard 4.2 says I can solve conservation of momentum problems, or I can apply the conservation of momentum to solve problems, or something like that. Okay? So we've got our givens. Now we need to use that statement of conservation to solve it. So let's go ahead and plug our things in. I'll keep saying it over and over. You do not have to use this chart in order to solve these problems. In fact, later on in the unit, we may just not, I might not give this to you every single problem, but you can organize it this way, right? It's an organizational tool. And then we've got 0 for the total before. Kilogram meter per second for that one. And then after, we've got 1,500 VF and 4,500 VF. We can put those together. Oops, come back. There we go. So the total before is just going to be 22,500 is equal to 6,000 times the final velocity. This line right here, the conservation momentum line, is the physics. This is just algebra now, right? Solving for VF. How do I get VF all by itself, friends? Divide by 6,000. Thank you. And you find that VF, whoa, hello. Why are you not working today? There we go. VF is equal to 3.75 meters per second. Let's do the graph too. Why not, right? Always good to know that you know what's happening. So let's go ahead and draw this. The initial is going to look kind of similar to the ones that we've drawn before. So it's got some velocity here and that truck is not moving. And then what happens after the collision? They're going to go together, like the interpretive dance version. Tell me about the slope of the line after as compared to before. It's going to be less than the pink one, right? More than the green one, technically. Yeah, but less than the pink one. Quite a bit less, honestly, because it was at 15, and now it's only at 3. So it's going to be pretty close to 0, but not quite. We'll see how we can do here in terms of drawing that picture. Something kind of like this, maybe. And then that one's going to stick right next to it. How are we doing, team? Is this okay? Okay. The thinking process is important here. The actual doing of these problems is pretty straightforward, I think. Today, after I do a little bit more talking, I'm going to give you some problems to work. There are just 4 more Muppet conservation momentum problems. This is the kind of thing that you would expect to see tomorrow on the check-in as well. Okay. So I spent some time, kind of maybe later than I should have, getting things organized and getting things graded, and I'm getting closer. And I wanted to give things back to you today so you've got some updates. Question on this? Yeah. Go for it. Are you just looking for the question I think said, what is the final velocity? Yes. So that's it's a good question though. If the problem says, what is the final momentum, right, then you would need to put that in there. Yeah. Good question. You had your hand up earlier, Sam, and you were going to ask a question, but I don't remember what it was. Okay, cool. Excellent. All right. So I'm going to hand back some things, and I want to explain a couple of pieces to you before I hand things back. Okay. So I'm going to hand back just, like the piles for tables. And in those piles, there are your folders. The folders still have all of the old trimester 1 work in them. I have not touched them. They've just literally been sitting in my file. If you want to hold on to that stuff, you're absolutely welcome to leave it in the folder. You can't take it with you. Maybe you can leave it in the folder so you have access to it. If you don't want to look at it again, it's going to get confusing. You don't want to see it. Please put it in this box up here for assessment recycling. Don't take it with you. Okay? Don't put it in my other recycling. Put it right here. Does that make sense? So if you don't want it, that's fine. If you do, just leave it in there, and that's 100% okay too. In addition to the folders that you have, there is also going to be some of this work as well. Okay. The 3.1, 3.2 check-in was either blue or gray, depending on which version you had. The unit 3 check-in was, that's what it says, and it was 3.1 through 3.3, either pink or yellow, and then the test was green or gold. Okay, those 3 things are all in there. Some of you asked to and took a like a reassessment of 3.3 right before break. It was pink, so I wrote it in pink. I have not yet graded them, but I have them, and I will get them graded. Okay, so I wanted to let you know that I have them. They're not in your pile yet. Okay. In addition, also from before break is your 4.1 check-in. So this was the impulse momentum check-in that we had. This was the one that was handwritten. That sounds familiar to you. It was either purple or yellow. And then the 4.1 egg drop follow-up. This was the one that we did right after we did the egg drop stuff. Okay, both of those are in there as well. Okay, or in the pile as well. What was I going to say? If you would like another opportunity to reassess 4.1 before the test, I can print that off for you. I've got another assessment chance for you on that. But just know that for 4.1, you will have this reassessment opportunity. You also have the Unit 4 test that will be at the end of next week. Okay, and then there's also going to be the final. So there's lots of chances still 3 chances. For the Unit 3 things, know that there still is the final. We're doing the final just like we did last time, right? So you've got that last opportunity at the end of the try to do that as well. Okay, so I want to let you know that that's all in there. The other thing that I want to make sure that everybody's aware of is the way that the gradebook is working. So last trimester, I tried really hard to be a good, to play the game and really try to use Canvas for grades, and it just didn't work for us very well, you guys. And I think that's one of those things that we have to learn, right? We have to grow from. So I am going back this trimester to Power School, okay? And so I want you to know what it's gonna look like in Power School. I'm using exactly the same idea, the same format, all of that is the same, it's just that it will look different since it's in a different environment. Okay, so I just took a screenshot of a student. I don't even have any idea who this is. But if you look at Power School right now, you will see you will see spots for all kinds of things, all the way through the end of the trimester. The reason for that is it just takes a whole long time for me to actually sit down and do that. Okay, so during break, I sat down and like carved out a couple hours, and I just entered all of the things in there. It's just tedious. Okay, so there's a lot of stuff that's empty, and I don't want you to be upset about that. Okay, the 3.1 stuff is not empty because we've done things. So if you look down here, we've got the 3.1 check-in, the 3.1 check-in number 2, and then the 3.1 test. There were 3 things to do. Okay, the scores for those, for me, they look purple. I don't know what they look like for you, but they are in either case exempt. Your grade is not dependent directly on these 3. Just like we did last trimester, I take the top 2 scores, right? And that's what goes into what I have here is the 3.1 standard score. So the top 2 scores were 9s. I add a 0.5, so you get 9.5 out of 10. Okay? For the 3.2 check-in, there was a 7, a 9, and a 9. Top 2 scores were 9s, so it's a 9.5. Okay? And then for 3.3, there was a test and a check-in. This person got 7s on both. So the top 2 scores would be 7s, and that's a 7.5. If this person has taken the 3.3 reassessment, I will put that score in there, okay? And if that's a 9, then this would go up to an 8.5, but I just haven't done that yet, okay? When I put things in, if you didn't do something, so let's say once I finally get these graded, you didn't do this, there will be a 0 here. You don't need to stress out about it. That to me just says there's no evidence based on that thing for me to give you a score. Okay, it's not, oh no, you have to do it. But if it's something like a test that you have a 0 in, then let's talk and figure out why I don't have a score in there for you. Does that make sense? Okay. The only things that the grade is based on are the ones that are in black, the ones that are actually being calculated. Okay. All the purple ones are just what I use to figure out that one. Does that make sense to everybody? Okay. Fantastic. All right. So what we're, oh yeah, go ahead.
I just have one question. So
yeah.
Only the lowest of the score that's exempt, or all 3 are exempt?
So all the purple scores, none of that goes into the grade. I don't know a nice fancy algorithm way to like make the computer do it. So literally what I do is I look at all the columns, and so it'll say Alex, then it'll have score, 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 and then I say, like I do it. I say, oh, which ones are the top 2, and then I put it in. So this, like these ones, I typed in based on these ones. Does that make sense?
Yeah.
Exactly. Yeah, and they will never be a part of, like officially a part of the calculated grade. Yeah. Yeah. Does that help kind of clear that up a little bit, hopefully? If you have questions, friends, please ask. I'm trying to get you the best score you can, right? That's what we're working towards. Okay. So what I'd like for you to do right now is send somebody from your table up to get the Muppets problems, okay? These are for you to work on, and then I will hand other things back. You've got the rest of the today? Do physics, please. It's a little bit confusing unless you are thinking about it the right way, so I just want to make sure that everybody is there. So the situation is this. Gonzo is standing on the canoe, okay? He's got his life jacket on, standing on the canoe, just standing there. How much momentum does he have? 0. Why? He's not moving, okay? So at the beginning of this story, Gonzo has 0 momentum, the canoe has 0 momentum. So the total momentum of the system before he jumps is 0. Are you with me there? Gonzo's going to jump this way. What's going to happen to the canoe? it's going to go the other way, right? Because the total momentum at the end has to be the same as the total momentum at the beginning. It has to equal 0. So the initial velocity for both objects is 0. The final velocity, if this is gonzo, the final velocity is 7.5 meters per second. And this is what we're looking for. We're looking for the final velocity for the boat. It will be negative. Okay. Since I've got your attention, I'm going to tell you right now also that the answers are uploaded onto Canvas for all of these things. I did miss when I was writing it out the negative, so I'm going to fix that in just a minute. But if you look at it like right now, it's not going to have the negative, but it should have all the numbers should work out. Okay. Question? Okay, we'll do it in a second. All right. So again, let me reiterate. In your folder, everything that was there when I handed it to you was old stuff. You can recycle it or not. Doesn't matter to me. At the end of the period today, I'm going to come collect all the folders and just put them back in a nice, neat order again. Okay? Keep working. Let's do lots of physics today. That means you can totally work with each other too. You don't have to sit in silence.